Continue from the previous video. So we know the distribution of the sample average will be close enough to the normal distribution if we have the large sample size. But the important question we want to ask, since they are the normal distribution, the center of the bell curve should be the population's average, right? So where we can find that? And also, if we have different sample size, will be the bell curve width will be different. So that's why we need to back to see the different sample size. Let's back to see here. So we have our sample size is 400. So we can see actually we run twice for the simulation for 10,000 times to get the sample size each time 400. Then we can find each time the twice the center actually very close to our population average. So now let's run the simulation again. So this time, how about we get the 900 sample size? So this one is the same thing. We will call the 10,000 sample mean. That's mean we will do the sample 10,000 times. And this time we will do 900 instead of the 400. That's why you can see they run much longer as well. So we will wait until they're done. Okay, they're done. So after we're done, let's put that in the same table for our result for the 900 sample size and the 400 sample size earlier we did run. So then let's put together for the histogram. So in this histogram, you can see this, the blue one is the sample size 400. So the yellow one is the sample size 900. They both run 10,000 times. And also you can see both these two results, those two distributions are close to the bell curve, right? Because you can see they kind of can shape the bell curve and they can be smooth. And also they have the they are symmetric. But one thing different is they have a little different width. But no matter the sample size 900, you see here, we can say that's the center about here. Then you put that down. The 400 center actually is around that area as well. Okay, so this one, what we can know. It kind of tells us, no matter your sample size is what, yeah, of course, should be large enough. But when they're large enough, even either that's 400 or 900, they kind of have similar center. Of course, this center close to our population average. And also both distributions are close to the bell-shaped curve. The only difference is for the 900 sample size, look like we have a narrow interval compared to the sample size 400. Okay, so test on your computer to see if you see the similar result. So from the result we see from the sample size 400 and 900, each one we run 10,000 times. What we see is the center of the distribution, right? Because either one, they have the distribution very close to the bell curve and they have similar center. Of course, these similar center are close to the population average as well. So compare again, think about again about the variability of the sample average. From the distribution we see from earlier, either sample size 400 or sample size 900, after we have 10,000, we run 10,000 times. They both have the curve close to the normal distribution. And also along with the center, they are very close to. The only difference is the spread. So the spread helps us identify exactly how the normal curve is the distribution of the sample average. The variability of the sample average helps us measure how accurate the sample average is as an estimation of the population, about the population average. So either 400 or 900, they both have similar center. So this similar center is a good estimate of the population average. So the only difference is the variability, the spread of the distribution. So the spread of distribution, we can identify how the normal curve is the distribute of the sample average. So if we want a specific level of accuracy, we need to understand why they have different interval, right? Why the sample size 900 have a narrow interval than the 400. So after we understand that, will they help us out to see in the future how large our sample size should be? Because you can see now, we just see they are different. So in the future, is 400 enough? Or we have to go to the sample size 900. Because if we can figure out a good size for the sample size, so then maybe we don't have to do 900 if 400 is good enough. That's what we will cover next. But before that, I want to make sure you understand the meaning for our sample distribution, the imperial distribution we just plot. So then please discuss with your classmates. Or if you don't have one to talk about now, make sure you pause the video, then think about by yourself for at least 1 minute or couple minutes. So then if you could, text with your classmates or talk to your classmates. Discuss what the answer will be. So that's the distribution we have earlier, right? So then we focus on the gold one. So this gold distribution, this gold histogram show the distribution of what kind of value, and each of that is what. Okay, so make sure you pause the video. I'm back, so I'm assuming you already got the answer. If you still not get the answer, make sure you pause the video. Now I will have the answer to talk about. So since we talk about the gold histogram, okay, so this one we say that's 900. But this 900 is what? Is the sample size. So since we talk about this whole histogram, is the distribution of, is the 10,000 sample average. From each sample, we have 900 sample. So that's why it's the B. We have 10,000 value. We illustrate this histogram. So each of these 10,000 is what? It's a randomly sample flight delayed or an average of flight delayed. Right, so that's an average flight delayed, right? An average flight delay from the 900 sample. Okay, so if you're still not for sure about the answer, go back to see our lecture file. So actually this one, the histograms came from this one. So this one is, we got the 10,000 samples from 400 each time and from 900 each time. Each time we got the 400 sample, we got the average delayed. So then we do 10,000 times for that. So since they talk about is the gold one. So the gold one actually is the sample size 900. So each time we got this 900 sample, then we find the average delay. Then we get 10,000 times to illustrate this histogram. So that's our discussion question. Continue with our discussion question. The gold histogram show the distribution of 10,000 value Each of that is the average of 900 random sample flight delayed. So the blue is the histogram show the distribution of 10,000 values. So each of that is an average of 400 randomly sampled flight delays. They both pretty good. It's the bell shape. The only thing is the larger sample size, like the 900, they have narrower the bell shape. So this one actually is what we want to continue to look at that. So we can see the larger sample size have the narrower bell curve, but how that's important. How that important for the larger sample size, the narrow of the bell curve. So one thing is we need to think about, actually the bell curve, the width related to what? Remember earlier we say the center is the population average. So then this 900 sample size each time, we have a narrower interval. So on the other hand, remember we talk about we have the curve, when the curve from the top going down, their slope is very high. Then they kind of smooth out a little bit. And between the smooth out and between the still and smooth out, we have a point of inflection. From this point of inflection can help us to find the standard deviation. So on the other hand, we got the center, they are very similar. But one thing is, for the bigger sample size, they will have a narrower interval. On the other hand, their standard deviation may be closer to our center, right? Because if you see this one, the 400, we got the stiff, then we smooth out. So then here is the point of inflection. So kind of got some idea, right? But not enough, right? So this one is 400, this one is 900. How about we do one more test? So this one we try to quantify the effect of the sample size. The sample size earlier we see they have similar bell curve distribution. Their center is very close, but the only difference is the interval. So that means the sample size will affect the interval, the width, the length of the width. So then here we write another function. In this function, what we want to do is we want to still specify your sample size. Okay. But one thing is, besides we plot and summarize the sample mean, we also get a little bit more information. You can see the first beginning, we still call our 10,000 sample mean. You pass the sample size, so that's why we have our 10,000 value distribution. Then we put in the table, so we can plot that. But after we plot that, let's print out some information we can compare. The first one, sample size. The second one, population mean. Then the average sample mean. So these two should be close to the center. Population mean, definitely that will be the center. So then the sample mean will be the center for the distribution. Then let's discuss, let's observe more about the standard deviation. So we display the population standard deviation. Then we calculate our standard deviation from our sample mean. Then let's get a ratio for our population standard deviation and the sample deviation. Then we will plot that on the histogram. Okay, so of course we will run for three different sample size. So here you will see 100 will be a little faster. Okay, let me see what the arrow is. Yeah, here they complain we didn't calculate standard deviation. So let me add standard deviation earlier. Yeah, so the error we see earlier is we didn't have the delay STD defined, so that's at delay STD earlier in this center. So that's later we will have that. Okay, or you can just add, if you have the same error happen, make sure you will add somewhere for the delay STD. Delay STD you can add the just from your use np.std. Okay, so after we have that, so then we can run again for this one. Okay, so let me make sure I also run this one. Okay, so that's our sample size 100. So that's over 15 minutes. So I will talk about this one in the next video.